All right, this is Math 209, Week 1, Section 5.3, more multiplying. All right, so when we are multiplying, I am going to show you a method that you have probably never seen before. I want you to try and use it rather than your system that you used back in the day with high school, all right? So when you are multiplying two polynomials, I want you, because this is a binomial, meaning there's two terms, and this is a binomial, meaning there's two terms, you're going to draw a 2 by 2 box, all right? And then on one side, you're going to put t plus 3, t, and then plus 3. And then on this side, you're going to do t plus 4. So it's going to be t plus 4. All right, so now this is called the area model. I want you to think about, what is t times t? Oh, that's t squared. What is t times positive 4? That's positive 4t. Then what's down here? Positive 3 times t, kind of like your times tables chart, right? So that's going to be positive 3t. And then over here, positive 3 times positive 4 gives you positive 12. So now you have these four terms, all right? You have t squared plus 4t plus 3t plus 12, all right? This is actually an optional step. Basically, all I did is I took these four terms and I wrote them down here. I see I've got some common terms right here, like terms. So this equals t squared, because he has no other like terms. Then I've got plus 7t, because 4t plus 3t is 7t, and then plus 12. All right. You may have learned other systems in high school back in the day. I want you to try and use this area model because it's actually going to help in later videos and later sections in Math 209. And again, this is called the area model. So using that area model, we are going to multiply x plus 4 times x plus 7. So it's going to be a 2 by 2 box, and it's going to be x plus 4, x plus 7. So x times x is x squared. X times positive 7 is positive 7x. Down here, positive 4 times x is positive 4x. And then right here, it's going to be positive 4 times positive 7 is positive 28. And now when I'm simplifying, this guy has no like terms, so it's just x squared. I can see that these guys are like terms, so I've got positive 4x plus 7x, that's positive 11x. And then I see that this guy has no like terms out of the 4 that we're adding, and so that's plus 28. And there we go, using the area model to multiply. So, same, we've got a 2 by 2, because this is a binomial, 2 terms, and this is a binomial, 2 terms. So we're going to draw our 2 by 2 box. And this becomes x minus 5, and this is x minus 9. And now x times x, x squared. X times negative 9 is negative 9x. Right here, it's going to be negative 5 times x is negative 5x. Tricky, right here. Negative 5 times negative 9 is positive 45. So what are our terms when we simplify? Well, the x squared has no like terms, so it's going to be x squared. But we can see these two guys right here are like terms. So you have negative 5 plus negative 9. So that's going to be equals negative 14x. And then the 45 has no like terms, so it's plus 45 right there. All right, so now it's just the terms that we're multiplying are getting a little bit more complicated, but really the math itself stays pretty the same. Pretty easy. 4v minus 3, 5v minus 5. All right, so now using our distributive property, 4v times 5v, So that's going to be 20v squared. Then right here, 4v times negative 5 is negative 20v. And then down here, negative 3 times positive 5v is negative 15v. And then right here, negative 3 times negative 5 gives us positive 15. So now what are our terms? When we simplify, we're looking for like terms. Well, this guy has no like term, so we're just going to write down 20v squared. But these two guys right here are our like terms, so we end up with negative 35v. How did we get that? Negative 15 plus a negative 20 means we have negative 35 altogether. So negative 35v plus 15, because that 15 has no like terms, and so there is our product. All right, more of the same. It's a 2 by 2 again. And you get 2b minus 3, 2b plus 3. And now we're ready to start our multiplying. So 2b times 2b, that's going to be 4b squared. 2b times positive 3 is positive 6b. I hate it when the 6 and the b are right next to each other. That looks too similar. Negative 3 times positive 2b, so that's going to be negative 6b. And then right here, negative 3 times positive 9 gives us negative 3 times positive 3 gives us negative 9. And so now we're ready to combine our like terms. Well, the 4b squared has no like term, so we're just going to copy him down. Here's some like terms, and they cancel each other out. Negative 6 plus 6, they cancel each other out. So these guys cancel each other out, and we're left with a minus 9. So you've got 4b squared minus 9. Still doing more of the same. So again, I see that it's a 2 by 2. All right, and they're just kind of giving us a variety of looks at that same 2 by 2. It's not always going to be a 2 by 2. Some of these might have 3 terms, in which case your box is going to be a little bit wider, and you'll have 3 terms. But let's just keep going. So this is 14y plus 5. This is y minus 4. And don't forget, when the y doesn't have a number, it's a 1. All right, so now 14y times 1y, that gives us 14y squared. Then you have 14y times negative 4. So 14 times negative 4, what the heck is that? That's negative 56y. All right, and then right down here we have plus 5, or positive 5, times 1y. So that gives you 5y. And then lastly, positive 5 times negative 4 gives you negative 20. And now we're ready to combine our like terms. And we can see that this guy has no like term, so it's just going to be 14y squared. We can see that these guys are our like terms. So you have positive 5 minus 56. So there's a lot more negatives than positives. And if you think about a head-to-head battle, so that's going to end up being negative 51y. And then this guy has no like term, so it's minus 20, or negative 20. And there is your answer. More of the same. Again, it's a 2 by 2 grid. And it's going to be 1 minus 7a. And then it's going to be 1 minus 8a. And using our distributive property, 1 times 1 is 1. And it could be a positive 1 if you really wanted to think about it that way. And so you could think of these as positives. So now we have positive 1 times negative 8a. So that's going to be negative 8a. And then down here is going to be negative 7a. And then right here, so negative 7 times negative 8, so that's going to be positive 56. And then a times a is a squared. So really this is going to be positive 56a squared. So what do we have? Well, this guy has no like terms, so it's just 1, or positive 1. These guys are our like terms, and you'll notice the like terms are almost always going to be on that diagonal. Negative 7 plus a negative 8, that gives us a negative 15a. And then we have this guy right here is another like, has no other like terms, so it's going to be plus 56a squared. And there you go. You can write it like that, or you can write it in what we call descending order. You look at the exponents and you put the highest exponent and then you work your way backwards. So that's another way you could have written the exact same answer. And, ooh, we're getting it fancy because now we have some exponents being thrown in there. All right, so we've got 5x squared plus 5, because that was this part right here. And now we have 2x minus 6. 2x minus 6. So I'm going to zoom in a little bit. So what do we have right here? Well, it's going to be 5 times 2 is 10. And then we have the x squared times the x, so that's going to be x to the third power. And then over here, you've got 5x squared times negative 6. So 5 times negative 6 is negative 30, and then x squared. What's going to go down here? We have a positive 5 and a positive 2, so that's going to be positive 10 because we're multiplying. And then the x has nothing else to be multiplied by, so it's just x. And then lastly, right here, it's going to be positive 5 times negative 6, so that gives us negative 30. These guys are not like terms because you don't have a variable down here, so we can't combine those. Don't get tripped up by that. And so let's start combining our like terms. This guy has no like terms, so it's 10x cubed. And you'll see that these guys, what traditionally we've been having a lot of diagonals, but there are no like terms here. So we can write them down here in any order, but traditionally we go from greatest exponent to lowest exponent. So negative 30x squared plus 10x minus 30. So no common or like terms. And the last one, finally, we have a trinomial. All right, so what does that mean? So it means one of these terms is actually product and factors has 3 terms in it. So we're actually going to do a 2 by 3 box, because the 2 is going to be the a plus 2. So there's our a plus 2. Now the 3 is because we have 3 terms up here. We have a squared, we have minus 4a, and we have plus 4. So now that we've got our area model filled out, let's multiply. So a times a squared is a to the third power, and then a times negative 4 is negative 4a squared, and then a times positive 4 is positive 4a. And then down here, positive 2 times a squared. So that's going to be positive 2a squared. This is positive 2 times negative 4a. So that's going to be negative 8a. And then lastly, positive 2 times positive 4 is positive 8. So where, and we're going to simplify, right? So does this guy have any like terms? Nope. So we just write it down. But we're going to notice that, hey, wait a second, right here along this diagonal we have like terms. We have positive 2 minus 4, so that's going to be negative 2a squared. Negative 2a squared. And then look at this, we've got like terms right here. We've got negative 8 plus 4, so that's going to be negative 4a. Negative 4a. And then this guy has no like terms, so it's going to be plus 8. And there is our answer.